Hello guys, in this video I'm going to teach us switch and lighting point connection for both conduit and surface systems. So this is a load, this is our lighting point, and this is a switch. Some of our buildings are conduit wired while some are surface wired. So for surface wiring, you're likely going to find a junction box. That's what we call a junction box. So whether you have conduit wiring or surface wiring, this video will enable you know how to navigate your way around issues concerning switch and your lighting system. So for a surface wiring, this is a lighting point. We have the live terminal and the neutral terminal. For surface wiring, you can see black at your switch point. Okay, that is why I used a black cable here, but this black is not neutral. So we are going to find out as we move on. So then we have our supply. This white is our live and this black is our neutral. So let's see how this connection goes. The first one is red of light to black of switch. This is our switch. Red of light to black of switch. With the aid of a plier, I'm going to connect. It is not yet energized, but make sure you don't have physical contact with these naked terminals. So we've connected red of light to black of switch. The next is black of light to black of supply. This is our supply. Black of light to black of supply. We connect as well. Now after that, we've connected black of light to black of supply. And then the next one is red of switch to red of supply. So this is the connection, guys. Red of light to black of switch. This is for surface wiring. Black of light to black of supply. Red of switch to red of supply. All right, this joining we are seeing here, all this joining, you find them inside a junction box of a surface wiring. So, but this is just the connection. So we are going to test our connection and see if the light turns on. Okay. Now let me power it from the wall socket. Good. So this is our switch. I'm going to turn on now. Let's see if our connection is through. All right. So this is it, guys. Switch on, off. So this is just the connection for surface wiring, for a lighting point. So this is how it is connected. Red of light to black of switch, black of light to black of supply, then red of switch to red of supply. This is the connection. This is for surface wiring. This is the only place you may find black wire in a junction box. All these joinings you are seeing here are being made in a junction box. Okay, so peradventure you have a surface wiring like this and your light is not turning on. Okay, so and you've certified that your switch is in on state. Okay, if your switch is in on state this way and yet your lighting point is not turning on, so you can test for voltage at the lighting point area. Okay, let me put this off. So you can test for voltage at this lighting point area when your switch is on. Let's do that quickly. All right, this is our meter. This is our multimeter right here. This is our multimeter here. So if your lighting point, if it's not turning on, you can test for voltage across the lighting point terminal here, the lamp holder terminal, sorry. So as you can see, it's giving us 0 voltage. All right, so you go and check your switch. As the switch is on right now, if we check, we're going to get some voltage reading. As you can see on the meter, we are having about 160 volts AC. So if you are getting light here and yet your lighting, if you're getting voltage at the lamp holder terminal and yet your lighting point doesn't turn on, your bulb doesn't turn on, then you should bear in mind that it's either the bulb is burnt out or your lamp holder is bad. All right, so but if your switch is on and you don't get voltage reading at the lamp holder terminals, then know that something is wrong with your switch. It's either the common is not supplied. All right, so this is the common. This is the common. So how to check? If you test for voltage here, you're not going to get any voltage because this is just live from the common transferring to the branch going to your lighting point. So for you to know if the live wire coming from the distribution board or coming from another switch is energized, you have to pick neutral from anywhere. Okay, so you can pick neutral from a socket, but this is our neutral link here. All right, so this is our neutral link. So whether the switch is on or off, there should be, if the supply line, that's the red line supplying the switch at the common terminal, if it is energized, it should give you voltage reading there should be voltage reading across the common terminal and neutral anywhere. So remember, this is neutral, right? This right here, I don't know if you are seeing it. This is neutral and this is our common. So provided the common line is through and is energized, we should be getting voltage reading. So let's see. Good. So we still have about 160 something volts AC, which means this line, this red line coming from the distribution board, the circuit breakers of the distribution board, it is energized. Okay, so if it is energized and when your switch is on, your light doesn't still turn on, then you replace the switch. It's as simple as that. So but if you don't get voltage here, if you don't get voltage between this hot line from the breaker and a neutral point, then you know that you have to trace to the distribution board, the line, the circuit breaker supplying this cable from the distribution board. You have to rectify if it is in order. So this is just how to go about troubleshooting issues concerning your lighting point. Okay, so but the most basic challenge you will be facing is replacing a dead lamp, changing a lamp holder, or replacing a bad switch. So it's very rare to find a situation whereby the circuit breaker, the supply line from the circuit breaker is having issues, unless there is a problem. Okay, sometimes a lamp holder may be bad and breach this terminal, and this terminal may breach internally, causing the breaker supplying this very cable to trip from the distribution board. So this is just a summary of how to troubleshoot lighting point issues. So the next thing we're going to do now is the conduit connection for a lighting point. Alright guys, let's now observe the conduit connection for a lighting point. So for a conduit wiring, a pipe is laid internally, so you're not going to see wire running up and down the building, you just see the points. Okay, so for a lighting point, there's nothing like a junction box, no joining, you're not going to see any junction box anywhere. So this is how the connection goes. This is from your distribution board, red and black, okay, live and neutral. Okay, this is my red. All right, so from the distribution board, live comes straight. Remember, this is not energized, please. That is why I'm able to touch it. Okay, so from the distribution board, live goes straight to the common terminal of the switch. All right, no joining. Then black from the distribution board goes straight to the neutral terminal of the lighting point. Neutral terminal of the lighting point, that's the neutral. All right, while the red, that's the live wire of the lighting point, goes straight to the L1 of the switch. Okay, so this is just the connection, guys. There is no joining, no junction box anywhere. Live from the distribution board comes to the common terminal of the switch. All right, red from the lighting point comes to the L1, the branch terminal of the switch. Then neutral from the distribution board goes straight to neutral of the lamp holder. Okay, so remember, you can still pick neutral from anywhere, maybe from any nearby socket, from any nearby lighting point. You can pick neutral from anywhere. While the live, also the live that is coming to this common, if there is a nearby switch, you can pick it from there. If there is a socket, you can pick it from there. So but whenever anything goes wrong, you trace it back to wherever it picked from, whether it's picked from another nearby switch or socket, or it's picked from the distribution board directly. So wherever is supplying this very cable, if it has any fault, there will be no current to this place and nothing will be transferred to illuminate our bulb, right? The neutral link may be okay, but if this is not in order, if this is not true, it won't work. If the neutral link as well has a fault, it won't work. So we already know how to test for voltage across these are live, so you can pick neutral from anywhere, okay, to confirm that this line is true. To confirm whether the neutral link is okay, you place your voltmeter here. You place your voltmeter here at the neutral and test any other live terminal. If it does not give you voltage, then you know that the neutral link is bad. If you keep one probe here and one probe at any other live terminal, and if you don't get voltage, then this neutral link is bad. To test the live link, if it's bad, you place one probe here and look for neutral anywhere. All right, if you don't get voltage across this line and any other functional neutral line, then you know that this very cable is faulty. It's not energized, so you trace where it is supplied from. So this is just the conduit wiring. Whether you have a conduit wire building or a surface wire building, you can know your way around issues that has to do with switch connection or your lamp holder. All right, so remember, a switch in the off state, it should not give continuity between these two terminals. Okay, so if you want to read continuity between the two terminals, you have to disengage it from the supply. So but when it's in the on state like this, there should be continuity between the two terminals. So this is another way to rectify if the fault of your lighting point is from the switch or not. So with this, you can always know your way around how to test for which exact fault is causing your lamp not to turn on. You test for voltage across the lamp holder terminals while your switch is on. If you have voltage there, then know that it's either your bulb is bad or your lamp holder is bad. Okay, so if you don't get voltage here when the switch is on, so two things are involved. Is either this line is not true or your switch is bad. To know if this line is true, we test this terminal and any other neutral. Okay, so to know if the neutral link is bad, we test the voltage across the neutral link and any other functional live wire. All right, so this is just how it's done. So to replace a switch, just the line from the distribution board comes to the common branch, from the lighting point comes to the L1. Okay, that's just how to connect a switch. If you want your switch to control anything at all, so the supply comes to one terminal, then red of what you want to control comes to the L1 on the branch of the switch, while neutral goes straight. This is another type of lamp you may find in your home. In my country, we call this POP lamp, but this is a LED lamp. LED stands for light emitting diode, LED. So this is a LED lamp, and this is the driver. This driver is nothing but a rectifier. A rectifier is like a charger. It takes in AC inputs from here and then delivers DC output. We already know what DC means: direct current, like the current you obtain from batteries. So it takes in AC from here and then delivers DC, which this lamp utilizes. So this is the input of this lamp. You just connect here this way and you lock it this way, while this place goes to the AC source. All right, so one terminal is live, that will be controlled by a switch, and one terminal goes directly to the neutral. All right, so we are going to test this and see how it works. Good. So as you can see, our light is on. Okay, so if you have your multimeter, once you plug this terminal, if you test here, what you're going to get is DC voltage. You can see there is an inner, I don't know how bright this, I don't know how clearly we can see this. There is an inner terminal. That inner terminal is where you place your red probe, and then there is an outer terminal, which is our black for the neutral probe. So that's how you test for voltage on a choke like this. You call it a choke or a driver, but it's actually a rectifier. You can see it's rated to 12 watts, input AC 85 to 265 volts, output it can deliver, it says 36 to 48 volts DC. All right, so this is the lamp. There are several DC lamps. We have this type, we have the tape light, just in case you meet any such light that makes use of a driver. So there is no big deal. Most of the time this driver can go bad, or the lamp itself can go bad. So but in most cases, all you have to do is just to buy a replacement. Then you go to your ceiling or wherever the light is mounted, detach it from the supply and then attach a new one. When you attach a new one, this part to the AC source, you take this terminal and plug it here, put on your switch, and the light will turn on. All right, so that is that for such lamps, just in case you need such a lamp in your building.